Hi, I'm Steve Kimmer-Murray. Today I'll be presenting the Azure ML service. Azure ML is a cloud-based machine learning tool for predictive analytics. It's part of Microsoft's Cortana Intelligence Suite. Azure ML Studio is a browser-based front-end for building models and publishing them as a web service. It follows a similar workflow to other data science tools like R or Python, but it's GUI-based. It competes primarily on productivity for model building and integration. We'll use the data from a recent Kaggle competition to demonstrate Azure ML in a real-world example. Rossmann is a drugstore chain with over 1,100 stores located across Germany. They sponsored a Kaggle competition to forecast daily sales for each store for 6 weeks based on historical data. We begin by going to the Kaggle competition website, and if you're signing up for a free account, we download store.csv, test.csv, and train.csv. At 38 megabytes, the training dataset is well above the project guidelines, so we'll randomly subset the train.csv file from the Linux shell prompt, Cygwin in our example. We use the head command to get the header row and the shuffle command to subset the data. Next, we use RStudio to visualize the data. We open the script data visualization.r, but before running, we select session from the menu bar, set working directory, and source file location. Now, we run the script. We can see from the first density plot of sales that its distribution is reasonably normally distributed, but we do notice quite a few observations that have 0 sales for the day. In the second graph, box plot of sales versus the open flag, we can clearly see that 0 sales corresponds with observations where the open flag is 0. Therefore, we know we can safely predict 0 sales whenever the open flag is set to 0. When building our model, we'll take that into account and filter out stores that are not open. For the remaining violin and scatter plots, we can see that many of the features from the dataset have some correlation to sales. We will include all these features when we build our model in Azure ML Studio. Now, we're ready to sign up for a free trial of Azure ML. Now, from Azure ML Studio, we select datasets on the left and add in the rossmann.csv file. We do the same for the store.csv dataset. Next, select experiments in the left sidebar and click plus new on the lower left. Select blank experiment, expand Save Datasets on the left, and expand My Datasets, and drag both of our CSVs to the canvas. Now, let's visualize the data by clicking the circle at the bottom of the rossmann.csv node and select Visualize. From here, we can highlight columns and view their statistics and visualize them as a histogram or a box plot. Now we need to join the two datasets with the Join node. On the left sidebar, expand Data Transformation, expand Manipulation, and drag Join Data to the canvas and connect the two CSVs to it. Now click on the uppermost Launch Column selector and select the Store column from Available Columns and move it to the selected columns with the right arrow button. Do the same for the second column selector. This will join the two datasets by store. Now, drag Apply SQL Transformation to the canvas and connect Join Data to the first input. Click on the SQL Query script box and paste in the SQL code from the source code folder called Filter and Feature Extraction. This step filters out sales observations for stores which are closed, and we extract the sales month feature from the date of the observation. Now, let's see if this is working by clicking the Run button at the bottom of the page, and we'll wait until the execution is complete. Now, click on the circle on the bottommost node and select Visualize. If we highlight the open field, we can see from the statistics that 1 is the only value, and if we scroll to the far right, we could see our new feature. In the same manipulation folder on the left, we drag project columns to the canvas. and connect it to the previous node. Next, we click Launch Column Selector on the right and select the columns Store, Day of Week, Sales, Promo, State Holiday, School Holiday, Store Type, Assortment, Competition Distance, Promo 2, and Sales Month. These are the only columns we'll use to build the model. Note that we don't include open since all the values are identical, and we leave out customer since this is unknown at the time of prediction. Also from the manipulation folder, we drag edit metadata to the canvas and connect it to the previous node. Next, we launch the column selector on the right and select all columns except for sales and competition distance. And in the categorical dropdown on the right, select Make Categorical. This step ensures that all of our categorical features are treated correctly instead of being treated as numeric. Next, we wish to split the data to train and evaluate the model. We drag split data to the canvas from the sample and split folder and connect it to the previous node. On the right-hand properties pane, enter 0.75 for the fraction of rows and any random number in the random seed box. Now, drag linear regression, train model, score model, and evaluate model to the canvas and connect the nodes. Notice you can use the search experiment item search box on the left pane to find these nodes. Now, highlight Train Model node, click the Launch Column Selector on the right pane, and select Sales from the dropdown. This is the target variable which we are predicting. Now, we are ready to run our model. Hit the Run button at the bottom of the page and wait for the execution to complete. If it's successful, all of the nodes will have a green check mark. To see how our model did, click the circle at the bottom of the Evaluate Model node and select Visualize. We can see from the results that the model's R-squared, or coefficient of determination, is 0.78. So it's doing a reasonable job at our first pass of predicting sales. Next, click the Setup Web Service button at the bottom and select Predictive Web Service. A new predictive experiment will be created in a new tab. Now, we'll click the Run button at the bottom and wait for it to complete. Now click on the Deploy Web Service button at the bottom. The web service is now active. There are a few things to note on this dashboard page. The API key will be needed to make calls to the service from your application. Azure ML creates a custom Excel document with embedded macros, which lets you enter values into Excel and fetch the prediction from the web service. This is a very easy way to confirm that your web service is working correctly. And the API help page lists all the details about your service, including skeleton code in C#, Python, and R to get you started. Back at the predictive experiment page, we click on the button Publish to Gallery at the bottom. Here, we fill in the description of the model, upload an image for the model, and select whether or not to make it public. And then we finish by clicking the check mark and wait for it to be published. We then click the View in Gallery link. From here, you can add the experiment to your own Azure ML account and play with it yourself. The link is also included in the file linked to Azure ML Studio experiment.txt in the source code folder. To demonstrate how to consume the web service from an external application, we wrote a Python script which will read the CSV file and write the output to another CSV file. You'll notice the URL for the web service that we got from the API help page and the API key. We loop through the input file, and whenever a store is open, we will then set the values for our data to be passed to the web service. We call the web service, and the web service will return our prediction. We write the prediction to the screen and to the file. If the store is closed, meaning open flag is set to 0, we will predict 0 as the sales for that day. Now we're ready to run our Python program. You'll notice the results of each prediction for each observation is printed to the screen. It is also written to a file which is formatted especially to be uploaded to Kaggle. To see how we did, we submit the results file, kaggle_submission.csv, in the output data folder to Kaggle. We can see that our submission puts us somewhere in the middle to bottom of the leaderboard. It's not bad for our first submission with very little experimentation. From here, we may perform more extensive feature extraction for seasonality, holiday shopping seasons, back-to-school days, etc., as well as iterate through other algorithms besides linear regression to improve our model. In conclusion, Azure ML is an extremely easy-to-use tool for building predictive models. It's cloud-based, so there's zero configuration. Its real strength is that you can develop and deploy a model to the cloud truly in minutes. Azure ML's disadvantages are the latency may not be suitable for some applications where speed is a factor. In addition, being a vendor-based product, it does have some costs beyond the free tier and does not benefit directly from the open source community, though R or Python may be embedded in the workflow. Thank you for listening.